We're really glad to be able to host you here. We have a couple of Chime employees here. One to me. If you have questions about Chime or what we do, I think you get a sense of our culture just from looking around and seeing the stuff on the walls and floors, but not the ceiling. I don't think. I don't spend a lot of time here. So thank you, ChicagoRuby, and thank you all of you for coming out on this lovely June evening. Thanks.
All right, cool. Thank you. So some announcements and housekeeping items before we get the ball rolling. All right, yeah. Join us for our future events. We'll post our events through meetup.com and advertise our events on these Slack channels right here. Reach out to me if you need an invite to any of these Slack channels. All right. Interested in hosting? We're always on the lookout for organizations or companies who are willing to host our monthly meetings. If interested, you can reach out to Anton or myself, and we can give you more info. All right. Yeah. Interested in speaking? We'd love to hear from you. Feel free to reach out to Anton for more, or myself for more information. If you're interested in speaking but unsure what to talk about, or if you're interested in hearing a specific topic, we've compiled a list of potential topic ideas that members of our community have expressed interest in learning more about. Feel free to add your ideas on this Google spreadsheet here. There's a QR code to it. For moderation purposes, this Google spreadsheet is open for comments only, and admins like myself will add ideas from the comments onto that list. Yeah. We'd love your feedback. In the upcoming meetups, we are thinking of exploring alternative event formats and event times, different start times or end times, in the hopes of meeting the needs of our local community. I've created a survey so that we can gather your information or your feedback. So you can scan the QR code here, and it's also available on that URL right there. Okay, all right. Okay, if you're interested in supporting ChicagoRuby, either by hosting a different type of event like a hack night or lightning talks, code and coffee or whatever, we are so down. Let us support you, support us. Reach out to me for more info. Also, we're always on the lookout for potential sponsorships or partners. Funds from these avenues would go towards food for future events, travel reimbursements for speakers, ChicagoRuby marketing, AV tech, meetup fees, etc., and any other fees we might incur. Feel free to reach out to me for more info. Okay, well, he's not here today, but I want to give Daniel a big shout out and thank you to one of our co-organizers, Daniel. I wanted to acknowledge that Daniel will be stepping down from his role as co-organizer of ChicagoRuby. I'll note that this isn't a goodbye, and we'll still be seeing Daniel from time to time at our meetups. But I also wanted to say that we are so, so grateful for Daniel's contributions to our ChicagoRuby community. And Anton and I are so lucky to have had him as support as well as backup whenever we needed him. All right. Lastly, join us for our event next month. Next month, we'll be taking a little breather from our typical event format, and we'll have a Ruby drink up to enjoy, hopefully, the gorgeous summer weather. Location is still to be determined, but my guess will probably be at the Chicago Brewhouse Riverwalk, similar to what we did last year. So yeah, if you have a place in mind, feel free to reach out to me. I'd be so down. All right. And with that, I am going to turn it over to our speaker, or one of our speakers. So I'm going to stop sharing.
Jump back to the. Oh. We'll jump back to the screen. All right, so there are some difficulties. Still echo. Okay, so before we start, I wanted to ask a question. Who here has tried domain-driven design before? One person, okay, 3 people. Good. Okay. So my talk today is about combining Ruby on Rails with domain-driven design. I hope to inspire you to explore this area. It's a difficult and long journey to explore domain-driven design. I'm not gonna hide it. It's not like a lesson in 30 minutes or something, but I hope to inspire you to start this and get as much fun as I've had over the last 15 years of doing so. Okay. Okay, perfect. Thank you very much. Okay, so hi, my name is Andrzej Krzywda. My name is super hard to pronounce, so this is how you pronounce it. Yeah, thank you, Michelle. Thank you, Anton, for allowing me to speak here. And let me start with a personal story a little bit, but also a story that maybe more of us shared. So the first question here is, what happened in 2004? Do you know what happened in 2004 that may be connected to why we are here today? Ruby on Rails was released in 2004, exactly. The first version was released, I believe, in July, I think, in 2004. I was very lucky because I was following a blog of Pragmatic Dave, and I learned about Ruby and on Rails in September. So I was using the version 0.07 or 0.70. So yes, and that was the logo back then of Ruby on Rails. That was the initial logo, I believe. But there was something else that has happened in 2004 that is connected to our talk. And that was that this book was made available. So this book was published actually in 2003, but okay, 2004 it appeared in bookstores. So Eric Evans wrote this book in the domain-driven design world. This is a legendary book. It's called the Blue Book. And this one is actually, to be honest, very hard to read. So if you want to learn about domain-driven design, this is a hard one. In 2004, this is my city of Wrocław in Poland, by the way. In 2004, I was living in the city, and I was a very young and very idealistic programmer. And I was actually a Java programmer. So I believed in stuff like plain old Java objects and no getters in your objects. Something that I was very passionate about it. And plain old Java objects means objects where you just write in Java, of course, but there is no dependency on any framework, on any library. And no getters mean reduced number of getters. You shouldn't expose your data of your objects outside. So you can imagine my shock when I saw Ruby on Rails. And the first thing we do, we inherit from active record base or application record nowadays, which of course is a dependency on the framework, and we write business logic in such classes. And the second thing is that once we inherit from active record base, we immediately have like thousands of getters generated for us. So depending on the number of columns. So not exactly the design patterns that I was used to have, but to be honest, Ruby on Rails was so amazing, so effective, that how not to switch, right? It was just too good. Back then in 2004, 2005, Ruby on Rails was such a big productivity booster that can be compared only to nowadays AI, probably. Ruby on Rails was the AI of year 2004, 2005, I believe. What used to take some days in Java, in their previous web frameworks, now in Rails started to take like some hours maybe, or even minutes. Let me just, okay. So in 2004, I started introducing, instead of, hi, I'm Andrzej and I'm a Java developer, I started saying, hey, I'm a Ruby developer. That was a big change in my life. Meanwhile, Ruby on Rails became more and more popular. DHH was doing amazing marketing job for us to make it more popular. And this is a cover of a Linux Journal magazine from 2006. The quality is so bad because there are not so many pictures of it. So this is 2006. And in 2007, after 3 years of doing Ruby, I decided to start a company called Arkency. And that was, by the way, kind of almost like an accident. I didn't really want to start a company. I really wanted to do Ruby, but there was no company to hire me. There was no Ruby companies, Rails companies back then, especially not in Poland. I even moved to UK, but even there I couldn't find. So I moved back to Poland. I started my own company. And it was actually this way that I was a freelancer doing Rails, because the clients, they didn't care which technology we use, right? So I just sat down with some clients over coffee, and that was what was meant to be the initial meeting, like with them sharing, okay, this is our business idea. And back then, every business idea was a social network, by the way. So there was social network for dogs. I actually built a social network for gardeners. So there was just social networks, basically. And in the Rails community, we already have a starter Rails application called Loved by Less that was basically a social network immediately done. So when I was meeting those clients over a coffee, I immediately started generating and scaffolding the code and showing them immediately. So this meeting that was initially meant to be just getting to know each other, it almost finished like signing a contract and it's already done. You're doing this project. So that's how I got too many clients for myself, and I started hiring friends, Java friends or .NET friends, and converted them into Rails, and that's how Arkency started. In 2010, we kind of realized that Ruby on Rails is mostly about greenfield application, that you start greenfield applications, but that's not exactly where our competitive advantage can be. So we kind of decided to focus on helping with bigger Rails application. That was our goal. So from 2010, the mission or the whole journey with domain-driven design started. We have explored many different paradigms, many different architectural ideas, and we stick to domain-driven design because that was the best what worked for us, and we started learning this. In 2012, we worked with a client called Bileto. We have many clients, but this one is important because with them, we actually achieved since 2012 to 2025 right now, we still work with them, and we achieved 1 billion domain events. And domain events is an important building block of domain-driven design, as I will show in a moment. And we have extracted Rails Event Store, a tool which helps Rails applications to start using domain-driven design and domain events. And by the way, I didn't know that one of our clients has a quite visible marketing campaign here in Chicago. So I'm here already for 3 days, and I noticed many of Lemonade advertisements. So this is fast forward to 2025. We now work with their enterprise companies, so we now work with big enterprise companies too. And it was nice to see them. So we are now in 2025. And what do we have in the Rails landscape right now? I wonder if you agree that the main building blocks are active record and service objects. Everyone is using active record? Yes. Everyone is using some sort of service objects? Most of you, not everyone? Okay, that's interesting. Let's talk later. And due to my job and due to the company that we're running, I get to see many Rails code bases. I've probably seen hundreds of them. So that's why I see what are the patterns, that, okay, whether we can help this client or whether we can't help this client. So this is more or less what I see. Also what I see, especially with bigger clients, is that they're decided to take their Rails monolith and to split some microservices. And maybe write them in Ruby, but maybe write them in Go, Kotlin, TypeScript, and other languages, right? So that's also quite a visible trend nowadays. What are the benefits of I call it the Rails way architecture, by the way. So relying on active record a lot and using some sort of service objects. There are many benefits. We know all of them. Active record is amazing for building, for mapping the database to the UI, for querying, for building forms, even for JSON. It's really good. Associations and so on. Active record is amazing for such things. Service objects also have introduced a good thing for Rails code bases, because now we have those well-named services that capture the concept better. Plus, service objects allow us to know that if we have a concept of registering a user or submitting an order, there's probably a service object for that, right? So we can easily find it. Without service objects, we had to find many ways of active record, how you call .create or .new and then save. There's too many ways of doing this, so service objects allow us to have one place for this. And there's certain simplicity of this CRUD approach, create, read, update, destroy. We can easily go very, very far with this approach. And it's very business effective. You can easily start new Rails applications very, very quickly. So what are the problems of the big, and here notice please the bigger Rails applications. The benefits are really good for almost every Rails application, but what are the problems now? And again, my perspective is from looking at the bigger Rails application. And what is the definition of a bigger application is debatable. I would say more than 80 active record models is, to me, is a bigger Rails application. But the higher limit is actually, we can have 500 active record models and so on. So first of all, there are big classes. I wonder if you notice in your projects that certain classes can have like 50 columns or even more. Usually it's the user class. Very often it's another class that maybe your business idea is surrounded about. So if you have some kind of e-commerce project, then a product class will also be bigger and the order class will be bigger and so on. So this is very, very typical. And by the way, how do we get to 50 columns in one class or in one data table? We get there one by one, right? If there was 45 columns and someone had a debate in his mind, should I add 46? Of course, it's not my fault, right? So from the initial 5 columns, we easily get to 50 and it's no one's fault, right? It's acceptable. There's a problem of modularization with Ruby on Rails applications. When we have these active records, we use has many, we use belongs to. What happens actually is we have a network of objects connected to each other. You can traverse all the objects together. Once you get access to one object, you can go everywhere. And this is often abused. So this is often that from one object, you will get .your neighbor, .first, some data, right? And of course, this is now accessing, breaking all the design rules, accessing someone else's private data. We'll talk about it today. By the way, microservices, when I see them used, of course, microservices can be used in a good way. But very often what we are doing with microservices is we still have the associations, but now they are through the network calls. It doesn't really solve the design. It just makes certain things slower and there's no transactions anymore. Rails applications are also hard, I think they're hard to unit test, the bigger ones. For example, take this one of the classes which has 50 columns. How do you unit test it? In order to unit test it, you have to set up in an initial state, and the initial state needs to have all the 50 columns in specific values that are valid, right? So this is problematic, and we need some fixtures, some gems to actually unit test a simple class. And service objects, they came with a really good improvements to our applications, but also I wonder if you also saw these discussions in your team, whether we have .execute method or whether we have .call method in the service object or .perform. So there's many different conventions. Plus, what is probably more interesting is if you have one service object in your project, do you allow calling other service objects? That's a question. Do you allow calling other service objects? It's fine. It's fine, yeah. So, but this other service object, can it call back? Or do you have like a layer of primary service object and secondary service objects? And I've seen different approaches. So there's no like good bad answer, but I see that many, what starts as a very simple service object layer then tends to get complicated. So it's not like it's a problem of service objects. I actually very much like service objects. I think service objects are like a gateway drug. This open the door to interesting explorations, because after a while, you will have 100 service objects, and you will see that still some abstraction is missing. A service object was good, but still something is missing. Okay, there's coupling and cohesion. Coupling means that this, I told you about this dot 4 times. Basically, it means that this part is now coupled to this part. So you change the private data of one object, suddenly you break something here, right? So this is coupling. Cohesion is, every active record class has an issue with cohesion because we have like a huge class. Even if you use concerns, it's just cheating, it's still one huge class. And then you usually change one bit of this class at the same time. Cohesion means that you have objects that are basically things that belong together are there, and then usually they all change. So with active record, it's very hard to avoid this low cohesion problem. Tracking callbacks. This is my favorite one. If you have some active record and after create you do something, and then you go somewhere and there's after commit, and then you go somewhere there's before save, and again you have a hidden coupling between different objects. And performance-related ones, deadlocks in transactions and slow reports. This is all related to the problem that we actually have one set of data tables in the database, and we try to access them at the same time. Some transactions are writing this, some transactions try to read, some other try to update it. And in a bigger traffic, in a bigger project, of course, it leads to deadlocks, and it leads to connection time also at the end. Slow reports, it's nice that we have denormalized database structure. It's very often preferred. But what happens if you build some, like in your admin panel or sales panel, some reports that generate data from many different tables, the joins are very slow when there's a big scale. So that's another problem. And yeah, bigger Rails applications, it's very hard to onboard juniors. And nowadays, a big trend, AI is also, big Rails core bases are not really very AI friendly. However, if you have some of your experiences after the talk, I'm happy to share our lessons. So what is domain-driven design? It's the idea of mapping the business more into the code, which is very abstract. But what is most importantly, it's an idea of thinking that you have multiple domains in your code and you will have a different model. So this is a big change when you compare it to the Ruby on Rails applications, that now we will have a model per each concept. And the concept is basically whatever we have as business department. So sales, marketing, invoicing, billing, those would be the domains in domain-driven design. And we want to have models, different model per each of them. And the important rule, we don't get from one model to another model. We don't call each other. That's in domain-driven design. There are some rules for that, but it's not at the level as we do it in Rails. And there is a shared language between developers and business. This is quite useful. And in Ruby on Rails, we also have the same shared language between business people and developers, but it's very often the language of CRUD. So why don't we create this? Why don't we update the client? So we are not using business language. Instead, the business people are using developers language, right? They're using the CRUD language. And in domain-driven design, we also have a very big emphasis on the modeling. It's kind of like analysis. And by the way, the word model is a bit problematic because we call active record model. In domain-driven design, the word model is something completely different. It's like a bigger concept, most like a abstraction than actual code. Yeah, and DDD has strategical DDD. There is a strategical DDD and tactical DDD. And this is where I like it so much because in my other life, let's say, I'm a chess player. And in chess, we always say that if you have a good strategy, the tactics will always work for you. So if you have a good position, pieces are developed, the center is occupied by your pieces, your king is safe, then usually you will find some plan. Usually you will get the game going. And in domain-driven design, that's exactly the same. If you have a good strategic split into the business departments, into the different domains, the tactical patterns will always somehow work. You will always find a solution for your next requirements. But what are the problems with domain-driven design? After I tried them, and I failed actually domain-driven design many times. So believe me, there are many problems with domain-driven design, and there are many ways of breaking your application. So first of all, is a total overkill for small applications. It just doesn't make sense to use domain-driven design for small applications, especially if you build MVP and you don't know what is the business market validation here. It might be too early to use domain-driven design. It's more when you understand the business. There is a big risk of over-engineering. When we developers get DDD and we play too much with tactical patterns, we will create a lot of boilerplate code. For us, for Rails developers, is definitely a problem. We are not used to have boilerplate code. And yeah, developers focus on tactical patterns instead of strategical patterns. So they will focus on repositories, entities, and so on, not the strategy. So what could be the dream architecture if I want to combine Ruby on Rails together with domain-driven design? And what would be the goals here of such a dream Rails architecture, of course, based on my experience? So first of all, I don't want to invent any new stuff. Ruby on Rails already comes with many amazing techniques, solutions, and over the last 15 years, Ruby on Rails got really amazingly better. So every year when the new version comes, or every 2 years, I'm going to check if my dream architecture still makes sense. This is more like a moving target than actual something set in stone. And I don't want to invent new things again. I want to collect, okay, I will take this part of domain-driven design because it's good. And I want to combine it with this part of Ruby on Rails because it's good. I don't want to invent any new stuff. I don't want to be an inventor. I'm just stealing the ideas from those two worlds. So I want to keep what's great in Rails and keep what's great in DDD. Allow CRUD still, and that for my DDD friends could be a shock because in DDD they hate the word CRUD. They for some reason they didn't like it. While I think it's still many parts of our applications are still CRUD, and we should use CRUD as Rails allows us. But of course, we should allow rich domains. We should allow for certain domains in our code that it should be more rich, more bigger models. And it should be junior friendly and it should be AI friendly. That's my goal. Okay, so what is the result as of 2025? I call it domain-driven Rails. And again, that was a moving target. So for the last 15 years, it meant something different in different moments. This is the snapshot of what I think in 2025. I think that it's very handy to have a split between application layer and domain layer. And Ruby on Rails is very good at application layer, and domain-driven design is very good at domain layer. So this is immediately gives me some ideas what I want. And this is what I want. I want a big split between the application layer and the domain layer. And the application layer, it should be modularized. Apologies for the colors. I'm not great at diagrams, as you can see, but hopefully you can get the idea. The application layer, we are splitting this into things like admin panel, public-facing application. So here is a modularization based on the actors that are calling us. They could be people, or they could be mobile client. It could be, let's say, webhook because you're integrating with Shopify. Or it could be GraphQL because you have many frontends and people want to use GraphQL for this. So it means that the application layer, you have, for example, 5 modules. This is modularization at the application level. And in the application layer, that's where Rails shines. And that's what we have said about Rails way. This works really well. We have controllers, we have service objects, and we have a green thing, which I haven't yet introduced. We will get there, which is called a read model. It's a model for reading data. But here, what's important is that here will be a domain layer, and from application layer, that's a difference now, that we will now say from supply product service, we'll call command. We'll send a command object. Command is a very simple structure that it's just basically meant to represent an intent. We want to say, hey, supply a product by 1. Or if we import order services, probably we will be calling create order command or register order command. Actually, we will call probably multiple commands from this service object. Probably there will be many commands. Okay, we will get to the read models, but just to show, this is almost like a split here, application level. This is where you change the data. This is where you read the data. So we have all products view in the admin panel. So we have all products read model. We have all orders, or we have ledger, we have month report, and so on. In the public application, we show the offer, we show the card. So each of the application layer will have their own read model, which is almost like a denormalized data for their own needs, but we'll get there. This is how the code looks like. So if we, in admin panel, we have a way of adding a new product with a name, with a price and a VAT rate, then this is more or less the code that would be either in the service object or in the controller. And by the way, with this approach, service objects and controllers, they're kind of blending sometimes. So it's not so important where this is. In this case, it's actually part of the controller, as you can see, because we are rendering, we are redirecting. So what is happening here? We have only 3 fields. And we are calling create product with the ID and the name. So we are registering the product with a name. So that's a one command. As I showed you in this diagram, this is the application layer. It will send commands. It doesn't know how it's done. It doesn't even know who will do it. It will just create an intent. Then if price is set, because it can be empty, we will issue a command for setting product price. So that's the second command. The same with VAT rate. And of course, some validations. If something failed, it will come back. So how exactly those method looks? How the methods look? Create product is preparing this command and is using a concept of command bus. It doesn't really matter today what is this about, but basically it's just a way of pushing stuff. We don't have to know who will handle this. The command will be run somewhere. And by the way, it's nothing about background jobs and nothing about asynchronous. You can make it asynchronous if you want, but here is just a concept. Similarly with set product price and set product VAT rate. Okay, we still didn't see the actual commands, so let's look. This is what are commands. So commands are, there is like a intent of registering the product with product ID and name. You can see with the prefixes here, those are actual domains. So we are sending to a specific domain a command what to do. So from one form, we're actually calling 1, 2, 3 different domains, right? We're contacting 3 different domains. So what is the domain layer then? What is happening there? Domain layer is this part. So we are getting commands from the application layer. So pricing, hey, could you set a price for this product? That's all what pricing does, let's say. Inventory, hey, could you supply this product with some amount? And the pricing, and so the input is command, the output is event. Okay? And the result is events, which are, you see there, the arrows are pointing there, they're pointing upwards. So it means that we are publishing an event, and there is a concept of command bus and event store, which will handle who is interested in this. So when the command is issued, the command bus knows where it goes, and when event is published, the event bus knows who is subscribed to this. So the code becomes more declarative. The models, they will say, hey, I'm interested in this event. And the command, they will say, hey, I'm actually handling this command. Okay, so domain events are a way of communication, right? That's through the layer. So now we can, apart from layers, we have now 3 building blocks. And if you are getting lost a little bit, that's normal. I'm introducing you some new concepts here, new concepts. And I will try to also introduce them in many different ways so that hopefully something clicks. So aggregate lives in the domain. You don't need to use aggregates, but it's very popular. And aggregates basically is something that takes the command, takes some old events, because it knows how to restore the data from the events, and it produces a new event. So in our example, I have some example, okay. In our example, it will be like there was set price, so the event would be price set. Right? So there will be a one-to-one mapping. Very often a command and event is like one-to-one. The second building block is read model. I told you that this is for displaying reasons, right? So each application layer module have its own tables, and those tables are populated from events. So there's events where they come to the domain. I mean, the commands go to the domain. From the domain, it goes back as an event. And the read models, they say, hey, I'm actually interested whenever the price changes because I'm displaying a list of prices, so I'm interested in this. So this way, we get read models populated. And I will show you code in a moment. And the third thing is a process manager. And process managers are in between those 2 layers. And they're handling, they're basically, this is actually the most interesting part if your project is really business heavy and you have many processes in your business. So for example, whenever someone enters the room, they should sign something on the screen, right? This is like a business rule. And that's exactly what is process manager. Hey, we detected new person entered the room, so that's an event. And we issue a command, please sign on the screen, right? And very often processes are very basic mappings, like when this event happens, do this. When we, sometimes there are process managers where we say, for example, when we handle an order, So where the order was submitted by the client, where it was approved by the salesperson, when they provided the delivery address, we can issue a command. So those three things are needed. We can issue a deliver command. We can say, hey, everything is done. We can then issue this. This is a declarative way of implementing process managers that is not easily possible with Ruby on Rails right now, not with the active record pattern and service objects, not that easily. So, okay, this is how the directory structure of such an application that has domains, this is how it looks. So there will be like it could be part of Rails. So you can imagine you have app/e-commerce, or you can it can be a directory called domains. It doesn't matter that much. The convention usually to have app/domains. Probably that would be the most typical convention for domain-driven Rails architecture. And in here is Ruby code. And what's interesting, this Ruby code has 0 dependencies to actual Ruby on Rails framework. There is no dependency on active record. We saw that we are just getting command and we are publishing an event. There is no need for active record there. So that's how this architecture looks like together. And this is how we are. This is how the code looks like somewhere in the Rails application. We'll say, because those domains are actually in domain-driven design, we call them bounded contexts. So there are contexts which have boundaries. The boundaries mean that they are not talking to each other directly, usually. So this is a configuration. So each file is, each such domain has some configuration. The configuration is very simple. It's basically this. The CRM module in my project knows that if the register customer command is happening, we have onRegistration class, very simple class that will handle what to do. So such domains are usually very small. We have split a big applications into a number of very small models. So it's kind of simplification at the cost of certain boilerplate. Because you, as a Ruby person, as a Rails person, you could argue, hey, this looks like a boilerplate code, right? We are not used to writing such code. It feels like duplication, but that's kind of the cost of introducing domain-driven design. Sometimes there will be such duplication. So once again, to see the whole thing together, we get supply product service called from the admin panel, let's say. We are, so actually I don't have the domain of supplies, but let's say this is supply, and the product supplied event would be issued. And for example, all products read model would subscribe to this and it will update the data, right? And still part of the same transaction. We're not doing anything asynchronous unless we want to. We can say certain read models are built in background jobs because it's too heavy, so let's do it in background jobs. That's also okay. But the default is that we are using transactions. And you see here, I showed also the process managers part, because they kind of live in between. I believe they're more in the application layer, but yeah, it doesn't really matter. It's just in the diagram. It doesn't really matter. To me, they can belong to the application layer. And the same for public applications. So again, we have some controllers, we have some service objects, we have some read models. Each read model is probably one database table or more, but usually it's one. And commands and events are the input and output. And going back to this diagram, every piece is very easily unit testable, because it's very easy to say in a test, in RSpec or Minitest, hey, commands, this is via commands, we have the input. So given is the commands. So given were the first commands, then given is the next command. So when is the next command, and then we assert that certain events were issued. And that's all that we're interested in. We're not interested whether it's a very good unit, because it's not our job to test if it appears in month report, right? We are just focusing, given those commands, are you issuing those events? And the read model, very easily unit testable. Given those events in a specific order, what is the data that you're exposing? And by the way, read models are active records. So it's very easy to test. And the process managers, given there was an event, did you issue a correct command? So the three building blocks are very easily testable. And you can even say they are functions. So for those of you who like the functional programming approach, this is actually very close to functional solution. Yeah, and comment events as the input and output. Okay. So the aggregates are publishing events. And this is an example aggregate. Very, very simple class. Okay, this was, you can see I included aggregate root. It's part of the Rails event store. So this is a dependency. This is like some kind of external library. But this is mostly responsible for this, that when we call, when the command is passed, this method will be named, this method will be called. So we are now in the domain called invoicing. And in invoicing, we have a special concept of a display name of a product. Because very often when you have a product name, you want to have a different name for the catalog, you want to have a different name for the invoicing. That's very often a request from the invoicing department that they want to have different names. So we say to invoicing, for example, and that's again a process manager. So when a product was named, we want to call the invoicing with the same name by default, but it can be changed. And then we initialize event, product name displayed set with product ID and name. And this is published. Apply method is basically publishing. So thanks to aggregate root, we have this apply method, which is basically published. And that's all. You can call this method as many times as you want, because via events, this object is actually built. So if you change the name of your product on invoice 10 times, there will be 10 events to load from the event store, and it will be then we can issue the next event. Because maybe there are some rules like that you cannot, invoicing makes sense that maybe you cannot change your name to something that was already in the history, that there was already there. You can imagine some scenarios like that. So the history could be implemented differently. And if ever this request comes, you can easily change the logic in here that will have a collection of names, and you can easily check whether there was something in history or not. Process managers instead of callbacks. So what used to be a callback, you can now implement it as a process manager. So whenever a customer registers in our e-commerce, we want to send them an internal message saying, welcome to our platform. Usually it will be done as a callback, I believe, or in the service object, but this is how we implement it. So this is a process. As a process, it listens to events, and it reacts with a command. Again, very testable, right? It's a very simple code, nothing to really look at this. So I believe I showed you all the building blocks. Oh, read models, sorry, read models. So read models are a special block because originally you don't find anything about read models in the domain-driven design book. There's nothing about it in the blue book. As a concept, it appeared later. It's a concept that we can also model reads, especially the ones that are performance related. So they could be problems with performance. And basically a read model is I will actually show you this. So this is a piece of data somewhere on our website. I'm assuming we're using ERB here, but it works the same if it was JSON and frontend, JavaScript frontend. So we have a special database table only for this view. And we have a product active record for this. I'm not sure if I have shown this. Okay, so but here we declare product. Product is basically an active record class. It's a pity I didn't show the active record class, but the active record class is basically one line. It's class, product, inherit active record base. Because in the read model, we don't use validations. Read model is always populated from data from the events, which means it's already verified. We don't have to assume that it's wrong at the read model level. So I have this kind of DSL here for single table read model where we say, hey, when this event happens, we copy the name to our name. When code is, when the tax VAT is set, we copy the name. So basically, this is a denormalization. This is also something that we have to get used in as Rails developer starting in doing this. There is a lot of denormalization, but because everything is synchronized via events, it's always correct. It's always synchronized. Because the problem with denormalization is the risk if data gets not synchronized correctly. All right. Thanks to this changes, which is quite a lot again. That was 15 years of my life, and I'm not expecting you to follow every detail now and to repeat everything I said, but more to get the bigger picture. The domain event is the most important concept now in the communication between us, the developers, and us versus business. So we can talk, and actually event storming, anyone heard about event storming idea? Okay, 2 people Thanks. So event storming is a workshop where we get all the business people and developers, as many as we can. It's not always easy to get the business people together in one room. And we put sticky notes with event names on the wall. And we try to, even if your Rails applications currently doesn't use any events, you can make this experiment and try to get all the people and get them to agree what would be the events in your application. And it's funny to watch how people disagree. You will very easily get a conflict. Like there will be a group of people here debating how we actually register a client. There will be people there debating that the invoicing actually doesn't work as someone else says. And usually the invoice person will say, oh no, you're all wrong. And basically this event storming session actually shows what is wrong. But it shows the system in a different way. Another concept is called event modeling. And we had, I'm one of the organizers of Wrocław RB conference in Wrocław, Poland. And this year we've had Mateusz talking to us about building Heroes of Might and Magic 3 using events. And this is an event modeling technique where in one Miro board or in one, actually, okay, Miro board, you put the actual screenshots of your UI. So this is Heroes of Might and Magic. And you say, what are the commands, what are the events, and what are the read models? And you build this kind of flow of data, what is happening. And actually the event modeling people, they use this view as a backlog because they say, okay, imagine this wasn't implemented yet. And they say, this is one task. This is one story to be implemented. So each arrow is one task. This is second task. And by this, they can easily see visible. They will attach an icon of who is working on what. And this is replacing Jira for their applications. I haven't tried it, but I really like the idea in general. Okay, so once again, this was the big architecture, let's say. And last part of this presentation is how, if you given your current Rails applications, what you can do. Of course, it's a very quick run now. So first step you can do is use Rails Event Store. It's open source, it's free. It will get you this UI for looking at the events and storing the events. So already if you publish events from your service objects, let's say, it already brings your value. And no one should argue that you're introducing this because all it does is it creates two tables in your database schema. It's events and events in streams. And now you're allowed to publish events. And this helps a lot in debugging because those are domain events. And you can see, okay, user logged in, administration impersonated login. That was actually actual bug that we discovered when we had this concept of logging in as someone else in our application. So that was helpful. The second thing, after you publish certain events in your service objects, you can extract read models because now you have events. And remember, read models, all they needed for existing was events. So if you have events, now you can build read models. And by the way, that's often what we do as the first step when we are called to some projects and there are performance issue related to certain reports. It's too slow to generate some reports. We will do exactly this. We will generate the events and we will replace the report. Instead of having multiple joins, we'll create a new data table. We'll populate via events after every change. And we will show the data from the new table, right? It's much faster. Of course, it has some other drawbacks, but usually it's creating some performance gains. And the third step, turning callbacks into process managers. So that's a way of reducing the complexity of your active records, because at the end, you would ideally want to remove some columns. So we started with the user class being 50 columns. You can see that using those techniques, if you follow this architecture, at the end, you have multiple user, client, admin classes. Each of them will have 5, 6, maybe 10 columns. Okay, and the last part, but hopefully also interesting, like how many of you have already tried using AI in your Rails applications? Okay, that's quite a lot. Do you use it mostly as autocomplete with GitHub Copilot, or do you use it for something more? Generating tests, yeah? More, okay, the question was not specific. So with AI, the auto-completion actually works really well. That's my experience. That's not bad. I mean, it hallucinates sometimes, but it's, in general, at the end, it's still valuable. It's not that you want to disable it usually. At least that's my experience, what I see in the projects we work on. However, for generating some bigger portions of the code on one line, it's very often hallucinating too much. And what is the problem? The context that AI can fit is just too small. Our Rails applications are too big. That's another way of saying this. Or we have no modularization. With this architecture, even if introduced as a hybrid, because you will never get to this perfect idealistic architecture, but if you get to the point where your read models are separated, now you can use AI. Now you can use, I'm still, of course, that's part of my current experiments. I didn't want to share my conclusions yet because it's too early. But what my current experiments show, this AI was very easily dealing with my read models because it was very limited scope. It reacted to 5 events. There's one database table. There's one active record. It generates me tests. It generates me the code. Very, very super fast. So yeah, that's the problem with small context. And the same problem, actually, I didn't mention this, but the same problem with AI is the same problem with juniors. Juniors struggle with bigger complexity, of course. And we were juniors too, and we struggled at the same, right? So that the context is too big again. If you want to try this architecture, don't try it in your production project because you will probably fail. And it's better to start in a sandbox. And that's this is a repository, GitHub, Rails Event Store e-commerce. That's a result of 10 years of work of my team. And what started as a very simple sample project to show some orders actually evolved into non-trivial e-commerce application. It's still not huge, it's not production, it's mostly for educational purpose. But at least it shows Rails combined with domain-driven design in one code base. So you can look there and you can play with this. You can try to maybe create some new feature or fix a bug. It's definitely, I would recommend you to get a feeling of what it's like to work with this code. We will not learn from presentations, unfortunately, but we will learn from writing the code. So you can open this repository and see, okay, I would like to add some new column to this order. What does it actually mean? Okay, I need to extend a read model. Okay, I need to add a new command. Okay, what do I need? And you can, and using AI also, you can actually, AI is quite good at dealing with this code base because it's not so huge anyway. And yeah, this is also certain goals that we have with this project. One of the goals is also to present mutation testing as a practice. And mutation testing is a really nice way of checking your test coverage at a really good level. So almost all the domain, actually all the domain code is mutation tested to 100%. So that's another gain that you can get from looking at this repository. There are 46 open issues right now. So you can see if something looks good for you maybe to take and give it a try, and then prepare a pull request. And I promise I will review it and I will give you feedback. And don't worry, if you make it wrong, I will help you. That's my goal, to help people educate people with Rails and DDD together. I'm really enthusiastic about it. And that's it. Thank you very much. Are there any questions? Okay.
So it seems like you have a fairly distributed architecture there, right? In terms of having, you know, like the application layer, which receives requests from the outside world, and then it commands. Those commands flow through the domain layer, right? And eventually are persisted somewhere. How do you ever get like lost events, and how do you kind of guard against that? Because in the more bigger distributed architecture, you send messages around. Sometimes you would issue a message and something would go wrong, and it never gets to the persistence layer. So how do you guard against, lost events that might be mission critical for you? Like if you don't block until it's persisted, you run the risk of it not being persisted.
Yeah, so if we are talking about existing Rails application that we now extend by publishing events, the idea, because Rails Event Store, that now I'm talking about the tool, was actually meant to help existing Rails applications. We were not focused on greenfield applications, we're just focused on existing Rails applications. So the idea is that if it worked as part of one transaction already for you, and you are now just adding new inserts to the event store as part of the same transaction, then it's either inserted because the whole transaction ran successfully, or it was rollbacked, right? So it wasn't really persisted. So when you are just adding a new event, this is basically up to whatever worked previously. We are just extending it with one insert. But if we are talking about this big diagram and this big architecture, if you have any kind of asynchronous work, so background jobs, or you're sending something to microservices, we will first publish an event, and then it will be taken by the background job, right? So the background job will be actually subscribing to this in a way. You can think about it this way. So the event is persisted, but if the background job fails, its background jobs anyway should be idempotent, right? They should be able to run again. So there is not a new issue here in general. As long as you are keeping certain discipline, it should be fine. So we didn't have when we applied those concepts, correctly, we didn't have an issue that event wasn't persisted. We only had an issue that some of the background jobs were not idempotent. That was the problem, but that's the problem we anyway have.
Sorry, can I give a quick follow-up, just a slightly different topic? So you said that the read models are displaying based on the aggregate of the events. So if you have a huge amount of events, and they would have to, it's all event to aggregate them all through the history. Is there like a aggregator that runs on a cron that condenses them to like a smaller, more manageable amount, or do you always keep like the full history for that kind of thing?
You can use snapshots if you want. And that's a technique. Okay, I'll explain it in another way. Whenever an event is published, in the read model, we just change one tiny bit of one row, usually, right? So we're not rebuilding the whole read model. Usually it's not possible. Usually it's not needed. When it's needed, okay, that's an issue, but it's rarely a situation. Usually people, what they do is they will just do this one change at a time, because they're very quick and big number of small transactions. That's where Postgres shines. That's where MySQL shines. That's where SQLite doesn't shine probably. So this is a big number of small transactions, and this is usually efficient enough. But if you have a read model which is really very computation heavy, okay, you can use background jobs, you can do something else. But of course, then you get, as with any background job, you get the problem that maybe some data is not displayed immediately, right? We have to deal with some UX solutions for this.
Okay, thank you.
Okay.
Another framing for that is compaction. It's called log compaction for like events. And so you can do that at any time and change your projection. So that gets to another thing, which is, what do you see as the difference between so one thing, so I've implemented DDD in a few different projects now, and everybody has a different slice of the Venn diagram of DDD that they want to like use. I like yours. Yours is focusing to me on like the event side of things.
Mm-hmm.
What do you see as the difference between what you were describing here and like an event-sourced model, which is maybe more familiar in like game design or something like that?
Mm-hmm. So I didn't talk about event sourcing today, but actually this application and this diagram is using event sourcing. Event sourcing replaces active record. For me, event sourcing means persistence mechanism, right? So instead of persisting data in the last snapshot of data as active record row, we persist as number of events which led to the same state, and then we'll reload them, right? So in the aggregate, there was this on method that reload the events, and they changed it. So that's how I see event sourcing. This is only this is the difference between event sourcing and event driven. Event driven is all the communication. Event sourcing is a kind of a detail, okay, important detail, as you know, but it's basically the persistence mechanism. It allows us to get rid of active records completely. We don't need active records for the domains. We only use it for read models. And this repository, this project only uses active records for read models, and it uses event sourcing fully for process managers and for aggregates. So that's my view, how I see event sourcing. Many people say, no, this is a super important big thing, but I think if I'm trying to be precise with definitions, event driven is the big thing. Event sourcing is just a detail, like how it's stored, right?
Cool. And then my follow-up, now hand off to others, is so in my experience of doing this a few times as well, your first point is very important, which I think I would love to hear more on. I don't think I've ever seen this done from the beginning of a project. It's always a refactor, a rewrite. Yeah. Why?
So why don't we start with DDD immediately?
Yeah, why don't we learn from ourselves?
I always get this question. So I didn't tell the whole truth here. I would start with DDD from scratch because I feel skilled enough to do it from the beginning. For those projects where I know the business area, even for MVPs, is actually even faster now for me to do it this way instead of the architect record way. But I spent 15 years on this, right? So it's easier for me. I wouldn't recommend it for people who first don't introduce it in existing application. I think you have to learn somewhere. But okay, if you want to create your toy project somewhere, side project, then of course. But maybe your experience is different. Maybe you would suggest everyone starts from the beginning. It's maybe also okay. You suggest it?
I think that it's too difficult to look past the ease of starting in a framework that's already there, like Rails.
Okay.
So I'm completely new to this. So I'm completely new to this. Thanks for this presentation. It feels like this is RxJS for Ruby on Rails. How close am I, or am I way off base? Okay.
Yeah, you mean Rx as in reactive programming, right?
Yes.
This is meaning. Yeah, this is basically this.
Okay.
It's
That's all I got.
it's more a functional programming name for this. As I said, it's very friendly. So yes, that's. Yeah. And by the way, also I didn't mention this. I'm a big fan of Hotwire. This idea of read models, it works very well with Hotwire because if you use Hotwire with broadcasting, for example, you will update the read model, and the read model will now be responsible for broadcasting the event to the browser, right? So it will use WebSocket to broadcast it. So it works very well with Hotwire. Okay, I think that's no more questions. Okay, one more. Do we have time for more questions?
We can do one more.
Just one more question. Okay.
Yeah, I mean, I'll take all the time. Did you try? So you're going with this refactoring, right? You're working in a large code base, complex. I'm thinking of your bullets at the beginning of all your problems that you've grown as part of actually making a successful code base. High coupling, high cohesion. I've also had success instead of doing DDD, like working and decomposing those large active record, those 50-column active record models. Did you also see success with that? Did you try that and see failure?
Sorry, say again, like how?
So your example of like a God object like user, which is 50 columns or something like that. You can take an approach where you decompose that. You actually have like different you take your user active record model, and now we're going to decompose that into several independently operated user. Okay, you see what I'm saying?
So then it makes the writing side easier, but it makes reading a whole lot more complicated. Now you have a lot more joins usually. So that was my experience I did it. I tried this path. And when I approached the read models, I decided, okay, I don't like it. I prefer with doing this with events and so on. But definitely it is a way. I think it's in some cases I could see this when there are some teams where for some reason they don't like the idea of domain events at all. This is a way of solving this problem. If a team is very capable of CQL, for example, and they can optimize the new joins, that's a good idea.
Thank you so much.
Okay, thank you.
We're gonna take, what time is it? 7:26? Like a 2-3 minute break just to stretch your legs. Yeah. And then I think Alan and Fito, thank you, is already with us. So if you wanna hold off until maybe like 7:30, we'll get started again.
Oh, nice. Okay, let's switch
Brant,
the
if you
camera.
start talking, Brant. Oh, there we go.
Hey, Chicago, can you guys hear us?
Yes. Hey,
Hey.
everybody.
Hello from
Yes, they can
Chime
see us on the
in San
audience
Francisco.
their video froze, but we can.
Oh, nice.
Arena,
Folks,
you're in the
can-
back. Yeah. Okay.
Can you guys come closer to the center? Somebody?
So Chime is not just hosting a meetup in Chicago today. Chime is also hosting the San Francisco Bay Ruby meetup in San Francisco. We thought if we could possibly time it so that we could all say hi to each other. I think it's kind of worked out. So hello, am I even on camera? I'm not even on camera. Hello, San Francisco.
Hey.
Hi, Arena.
Hey,
Hey, Noel. Hi, Chicago.
hi everyone. Thanks for joining.
I didn't have anything really special planned for this. I just thought it'd be fun for us to sort of wave at each other. And they're just starting. They're just starting. We're about halfway through our stuff. So great to see you out there. And I don't know. Thanks for coming.
Yeah, it's pretty magical. 2 Ruby meetups at Chime offices in 2 different cities. It's kind of crazy. But yeah.
Right.
Great seeing all of you guys. And you seem to have great weather there.
That's an illusion.
Oh, okay.
It was, yeah. Okay. Thanks. All right, Brand, you can sign out, and then we can we'll go back to our day, and you can go back to your day.
Oh, and hi to Alan and Fito.
Yeah, Alan and Fito are here.
Cool.
Why aren't you here?
Well, thanks for the shout out. Happy Ruby coding over there, guys.
We're actually presenting in Chicago today, so.
Oh, right.
Nice.
All right.
Or can you tell us a little bit about what the topic is?
Was that for me or Arena?
Oh, what you guys are talking about?
Fito and I are going to talk about complexity and also why and how we are derailing our application.
Sounds like important stuff.
Folks in Chicago, excuse me, in San Francisco have already seen this talk. We gave it to them at the last meetup.
Okay, that's at least that. At least they presented at home first. Thank you.
Cool.
All right, have a good time. We'll need to disconnect because we want to record live stream. All this stuff.
Yeah.
All right.
Thanks so much, guys.
So, yeah.
Thanks.
Have fun. Yeah, super nice seeing all of you. Have fun.
All right. Hello.
Hello.
Hi. I don't know if you can see me or if it's still to the crowd.
It's pointed
to
at the crowd.
Okay, that's okay. I'm sorry. Oh yeah. I will let you guys get started, Alan and Fito. Yeah, feel free to share your screen, and the meeting is yours.
Thank you.
Thank you.
I am a WebEx user because I'm a Cisco employee, so it's taking me a moment to find the share button. There, you should now see an image that says derailing our application. If you're responding, I can't hear you. Nor could I understand that. Sorry. How about this? If y'all are ready for us to begin, give us a big thumbs up if you can hear us and you're ready for it. All right, there we go. Cool. So a couple of minor things first. We only have the one mic in this room and it's directional, so we're going to be swapping back and forth a little bit. Let us know if you are unable to hear us. We'll make sure that works. And with that, I'm just going to jump on in. Hello, welcome. Thank you for coming. We're excited that you guys are all there and we get to share this talk with you. My name is Alan Reidelhoover. My pronouns are he, him, and I lead the dashboard platform engineering teams for the Cisco side of Cisco's network platform organization. Excuse me, for the cloud side of Cisco networking platform. It's a mouthful.
Right. Hello, and I'm Fito from Sastrov. I also use the pronouns he, him, and I'm a staff software engineer on Alan's team. So, like Alan said, we're super happy to be here. It's our honor to present on behalf of Cisco, and we're going to be doing it at RailsConf this year. So we are rehearsing our talk publicly to gather feedback so that our presentation will be the best it can be in July. This is the third time we're doing it. But the talk is still in flux. You're actually getting a version a little bit different than what the folks saw at the SF Ruby meetup a couple of weeks ago. So please share your feedback. We'll share our contact information at the end of the deck. And with that, Alan, do you want to kick us off?
Sure thing. Okay, so we call this talk Derailing Our Application, but that is a bit of a misnomer. We are not actually removing Rails from our app. Rather, we're decoupling our business logic from Rails constructs because we found that Rails was both getting in our way and not providing enough structure at our scale. Now, before we dive into that, though, we need to share a couple of concepts that can help us establish some common language. So first thing we want to talk about is convex and concave payouts. It'll just take a minute. So a convex payout is one that only requires a small investment and usually results in a small loss, but occasionally results in a very large profit. This is venture capital. You make lots of little investments in lots of little experiments to see if any of them are going to pay off. Now, a concave curve or a payout is one that requires a large upfront investment and usually results in a small, reliable profit, but can result in a very big loss. And this is kind of like investing in retirement. You have a nest egg, you want it to grow, but you can't afford any losses. So you plan carefully and you invest conservatively. All right, so let's say you're starting a new business. You want to provide a service no one else is providing. Which payout curve are you targeting? Well, you're targeting convex. Why risk a bunch of money on something no one else is doing? Maybe the reason no one else is doing it is because it's a dumb idea, but there's a small chance that it could be the next big thing. So now let's say you're an established business like a bank and you cannot afford to lose any money or customers. So which payoff curve are you going to target? Well, concave, of course. There's lots of risk. It's a small reward, so you better do some upfront planning to reduce the risk. All right, does everybody understand convex and concave payouts? Right on. Okay, that's the end of our economics lecture, but I want to add something really quick. In the previous questions from the previous presentation, there was a question about why do we not start here with domain-driven design? Domain-driven design is kind of a large-scale thing, and it's really more appropriate at the concave portion of the application lifecycle, and I'll get into that in a minute. The convex portion is usually more along the lines of running small experiments, and the concepts from domain-driven design might actually get in your way early on. Okay, so how do we apply these curves to software development? So there's this guy, you may have heard of him. His name is Kent Beck, and he has a talk called 3X. In the talk, he shows how the convex and concave payouts are actually a single curve. Together, they form an S-shaped curve that represents the application development lifecycle with 3 phases: exploration, expansion, and extraction. Exploration is the convex portion of the curve. The goal here is to find the thing that's going to pay off big. Expansion is all about growth. You've found a thing, it is taking off, and it's your job to try and scale it as fast as you can. And then finally, once growth slows and you've accumulated a large customer base who you cannot afford to lose, the application enters an extraction phase of its life cycle, where here you've reached that concave portion of the curve. Your goal now is to eke out as much value as possible without risking loss. So knowing about this curve and the life cycle that Beck proposes here, and where you are on that curve can inform the decisions you make. For example, iterative development makes a ton of sense in the explore phase, but the extract phase may call for more planning, given the risks. So, where is Meraki on this curve? Well, when we started putting together the materials for this talk, we thought our Rails monolith was nearing the extraction phase of development. Turns out, not so much. The data is actually pretty clear. We're still expanding. To understand the challenges we're facing and why we're decoupling ourselves from Rails, let's take a look at how we got to this point. So, Meraki was founded in 2006. We were a startup with a crazy idea for a service that no one else was providing, remote network management over the cloud. So we set about exploring that space. It was uncharted territory. Rails had just shipped in December of 2005. We began our work on our monolith in April of 2006, and at that point, people were still writing fat controllers. No one knew the Rails way. We hadn't yet lived through the Ruby 1.9 upgrade. There were no RESTful routes. You couldn't chain active record queries, and you had to do dependency management manually because Bundler didn't exist. Plus, we weren't well-grounded, eloquent, or practical. But that didn't stop Cisco from acquiring Meraki in December of 2012, because they recognized that we were innovating incredibly fast. And that's despite the fact that the central concepts in our application were written long before any of those best practices were established. So by today's standards, our code was a mess. But according to Sandy Metz, in her post entitled The Half-Life of Code, most applications are a mess. And having a big mess may actually be a sign of success. It's certainly a sign that our application has survived a constant barrage of new requirements, added under urgent time pressure, driving our application toward disorder. And of course, as entropy grows, velocity gradually slows. But we've just been acquired, and all of a sudden we had access to way more customers, and they wanted products and features we didn't have. So our Rails app grew a bunch despite the mess. We went into full-on expansion mode. And at the end of 2012, there were only 38 active contributors to the code base. That was the point at which we were acquired. And we had about 250,000 lines of Ruby code. About 3 years later, at the beginning of 2016, there were twice as many contributors and over 500,000 lines of Ruby code. 3 years later, which is about the time Fito and I joined, the engineering team had doubled again, and there were nearly 1 million lines of Ruby code. You can start to see where this curve is heading. 3 years after that, there were over 250 monthly active contributors and more than 1.7 million lines of Ruby code. And then in 2022, Cisco announced that our most powerful Catalyst devices would also be manageable via the Meraki dashboard. That meant we needed to add support for several hundred products to our Rails app. So in the 3 years since then, monthly active contributors have more than doubled again, and we grew the code base to over 4.25 million lines of code. That's just Ruby, by the way. There's a JavaScript app and a bunch of other stuff. So during the explore phase, we built the central concepts of our application without the benefits of those modern Rails best practices. And by today's standards, our code was a mess. But at only 250,000 lines of code, it was probably pretty manageable. But early in the expansion phase, we saw significant growth in both our code base and our team due to the constant barrage of new feature requests. The growth in the code base led to some astonishingly large models and controllers that caused complexity to increase, making the code harder to understand, harder to change, and harder to test. And without adequate test coverage, we were unable to move as quickly and confidently as we desired. Furthermore, because the models and controllers were shared across the organization, no one individual or team could act to improve the code without either gaining consensus across the organization or imposing their solution on everyone else. So we wanted to increase our velocity as we continue to scale, but to do so, we felt we needed to look beyond Rails MVC architecture in order to reduce complexity and increase testability. We also felt like Rails wasn't giving us enough guidance about how to structure our application to support a team at our scale. There's actually dozens and dozens of teams here. So we needed to change our approach in order to address these issues. And that's what Fito is going to talk about next.
Sounds good. All right, so like Alan mentioned, we wanted to reduce complexity and increase testability. And to do that, we chose to modularize our code base in order to address those concerns. But we also wanted to improve autonomy and accountability. And so to address that, we added boundaries within our monolith to support these qualities in the code. So let's look at how we're applying these concepts to our Rails app. Now, the first thing we did was to teach people how to remove business logic from our controllers. Now, this is modularization. We're breaking big things into smaller things. So we broke our large controller actions into much smaller objects. And we started there for a few reasons. First, our business logic is the most valuable code we have. It's really what differentiates us from our competitors. And it's also where developers spend most of their time. So they're adding features, they're fixing bugs. So this is where we're really going to get the biggest return on investment from having high test coverage. So testability is key there. And second, controllers can be really hard to test. So they often require complex setups in order to exercise every code path in your controller action. The more logic you have in that controller action, the more cumbersome testing becomes. And so at some point, people just stop writing tests and they opt instead for manual testing or other solutions that are actually slower. So we restructured our code to make it easier to test via simpler, quicker unit tests that require less setup. I'm going to show you an example. Now, before I show you code, the code in these examples is made up, but it was inspired by real production code. So instead of networking concepts, we're going to use concepts related to coffee machines here. But just know that the shape of this code actually existed in production at some point. All right, so this is a controller that handles requests to update the settings of multiple coffee machines that belong to a cafe. Now, like I said, don't feel like you need to understand the code here. Instead, I want you to focus on the shape of the code and the variety of colors on the screen. Both of those things are easy indicators that there's lots of different things going on in this controller. Let me walk you through some of the high-level things that are going on. First, we have an active record transaction here, which contains a loop. And this is looping over an array of arrays, which contains a coffee maker ID and the corresponding changes to that coffee machine's configuration. Now, inside that loop is where most of the business logic lives. Now, this code is doing things like validating input, populating errors, is serializing a hash of changes, and then finally it saves the settings. Now, outside the loop, there's a little bit more business logic. The controller is creating a cafe event record, which is probably consumed by a different part of the system. Potentially, this is some sort of notification system. And then finally, there's some aggressive exception handling here and an ensure block in charge of rendering the response. Again, this is also a sign that the code has gotten out of control. Let's just rescue to be safe and deal with it. Like I said, there's a lot going on, but when we tackle controllers like this, we don't have to solve all the problems at once. In fact, our approach here is to first focus on the body of the loop. Now, before we go there though, we are doing this to make testing easier, but it is important that you have at least some high-level tests that are providing just enough coverage to tell us if we completely break the method. Just something that tells you like, does this run or not? So let's assume we have those and get started with the extraction. Okay, so here we've extracted a class called update water tank settings. This class encapsulates the procedure inside the loop and is now only concerned with a single coffee maker. Now this makes testing the logic much easier since you no longer have to think about HTTP requests or how do I log in a user and what does the HTTP response looks like. You also don't have to think about that loop. You can focus on the effects this class has on the settings of a single coffee machine. And as a bonus, it turns out that this procedure was primarily concerned with settings related to a coffee machine's water tank. That wasn't obvious when all the code was in the controller. Extracting this class gave us an opportunity to give it a more descriptive name, which makes it easier for new folks to find this code. Now, there's still a lot of logic left in the controller. So the next step is to extract the remaining business logic out into another class. Okay, so here we've created a new class. We call it update coffee machine settings and moved the rest of the business logic there. And if you look at the controller, it now looks a whole lot more like a scaffolded controller. It's only responsible for handling the HTTP request and sending the response. But it collaborates with a new class to build the response. Now, the new class, on the other hand, still has several responsibilities, and admittedly a lot more than we'd like. But we're going to defer that work for the next person to touch this file, because our goal here was not to arrive at a perfect design, it was to make it easier to test our business logic. And now that it's out of the controller, we've accomplished that goal. Now, extracting business logic out of the controller helped us achieve simplicity and testability, but extractions alone are not enough to promote the other qualities we wanted to see, like autonomy and accountability. And for that, we need some walls within our codebase. Now, these boundaries reduce the cognitive load across the entire engineering organization. An engineer now no longer needs to know about all 4 million lines of code. Rather, they can just focus on the code their team owns. And they're free to improve it without having to gain consensus from the entire organization. As long as their team agrees, they can change it up. All right, so we start with all the code in the controllers directory. But now that we've extracted a couple of classes, we have the ability to actually move that code into a different directory. Now here we've introduced a domain directory with a coffee machine subdirectory. And we moved the new classes in that subdirectory. Now, this directory structure provides you with a namespace where you could put all the business logic related to coffee machines. It also allowed the team to, that's the team that's in charge of building features related to coffee machines to take ownership of this directory. And now they can experiment with different approaches without requiring, again, like I said before, consensus from the entire organization. But they're also now accountable for the level of test coverage and flakiness that's related to this specific directory. Plus, with the coffee machine namespace in place, we can now even rename our classes to leverage the information that's already conveyed by the namespace. For example, update coffee machine settings could just be now update settings that lives under the coffee machine namespace. All right, the next step we took was to teach people how to remove business logic from our views, specifically ERB files. Now, views present a slightly different challenge. Starting with the fact that ERB files cannot be processed by community standard code quality tools like Flog and SimpleCov. And I learned recently rake stats also won't give you accurate data on them. So you can't get static analysis on them. And also their tests are difficult to write and can lead you to false positives due to the fact that you have to set all these instance variables for the view that the controller would ordinarily provide to the view. And once you do that, you're opening yourself up to the possibility that somebody's going to change the controller without breaking the view tests. So you have passing tests, but broken code. Plus, the embedded Ruby syntax honestly makes it harder to read than what it would be if you had just plain Ruby. So we restructured our views to make the code easier to test, but also with an eye to make it easier to understand. And as a bonus, we can also now measure the quality of the code. Let's take a look at an example. Okay, here on the left side, we have a controller that's in charge of rendering configuration properties for a coffee machine. Now, the controller itself is not doing much. It's just finding the coffee machine, setting a few instance variables, and then rendering a template. Now, on the right here, we have the view. or the ERB template. Now, this template contains the business logic that decides which properties get rendered under what conditions. Now, the output is a text file that has key value pairs that are separated by new line characters. That looks like this. It's just a plain text response. It has a list of properties. Each property is its own line. Each line contains the property key, followed by a colon, followed by a single space, followed by the property value, which may contain any number of things, including spaces. Now, when you look at this response, or in our case, we specifically determined that we don't actually need ERB for this. A plain old Ruby object could do it. But even if we did need ERB, most of this logic could be handled by a plain old Ruby object. So in this case, we're going to move all of it into a portal. Now, again, like I said before, we recommend making sure that you have at least a high-level test that will break if you do this wrong. So have some high-level tests before extracting this code. And assuming we have that, let's get started. Okay, here's the controller and the ERB template as we left them a moment ago. Let's replace them with a portal. Okay, so here we've created a new class called Coffee Machine Configuration. Now, this class encapsulates the business logic that's in charge of building those configuration properties. We've also pulled the code that calculated the instance variables in the controller, and we moved them into the new class. Now, the reason for that is that the variables were deeply embedded in the view's logic. The controller really had no use for those variables other than setting them so that the view can then access them. However, we left the code that finds the coffee machine in the controller because the controller does use that logic to determine what the correct HTTP response should be. And the new class does not really need to be instantiated if there's no coffee machine found. So we left that little bit of logic there. Okay, the benefits of this extraction are that the coffee machine configuration file is much easier to test than the ERB view. And we can now get coverage and complexity information on this new class. The controller is also much easier to test since it's responsible for fewer things, less business logic. Okay, let's take a look now at where this code should go. So we start with the code in controllers and views. We then replace the view with a pure Ruby object. And we can now put the new coffee machine configuration class in the domain coffee machine directory that we had created before and rename it to just configuration since it's now in the coffee machine namespace. Now, the next thing we taught people to remove is business logic from our models. Now, this might seem unnecessary or counterintuitive to some folks, given that skinny controllers and fat models is considered a best practice in the Rails community. However, we have a few reasons to move this logic out of there. Most of our models represent those core concepts in our application. And that, like Alan mentioned before, they were added early in the life cycle of our application. That made them magnets for code. And so the more code gets added to these models, the lower the cohesion and the higher the chance that methods will be implicitly coupled with each other. And so these models tend to become junk drawers, making it hard to draw boundaries around the code in there and take ownership. Also, putting your business logic in active record lifecycle hooks and scopes makes the code really difficult to test without actually creating the database. Now, once again, we restructure our code to make it easier to test and so that we could draw boundaries. Let's take a look. Okay, on the left, we have a controller action that's in charge of broadcasting details about a coffee machine. Now, the controller queries the database to find the correct coffee machine and then just calls broadcast details on the coffee machine model. And on the right, we have the coffee machine model. The broadcast details method checks various attributes on the model and builds a string that contains the machine's name, recent activity, and supply status. Now, same caveat as before, make sure you have a high-level test before extracting any of this code. And assuming we have that, let's get started. Okay, here we've extracted the logic from the broadcast details method into a new class called coffee machine broadcast details. Now, the class receives a coffee machine now and performs the same logic to build a string that contains the machine name, the recent activity, and the supply status. They might look super similar, but this new class has a few advantages. First, it is no longer implicitly coupled to the model attributes anymore, making it far more extensible. As long as it receives an object that responds to the same methods, it can be used in other contexts. You can even pass some immutable object, doesn't have to be active record anymore. Second, it's easier to test since the coffee machine object that you're passing in the initializer can be more easily stopped in tests. And finally, the code in the class is no longer accessible to other methods in the model. And this prevents that incidental coupling via referencing each other methods or instance variables within the model. Plus, and this is a big plus, we can now move it inside a boundary. We start with code in a controller in a model, and we then extracted a class out of the model. And we can now put that new coffee machine broadcast details class in the domain coffee machine directory and rename it to broadcast details. All right. That was a brief look at some examples of how we have and are extracting our code out of Rails concepts. And honestly, to summarize this approach, we're just putting our business logic in plain old Ruby objects. And we're moving these objects into namespaces to create boundaries around the domain concepts. Now, if we bring together all the classes that we extracted, the directory structure looks like this. You may have noticed that these classes are not organized by pattern or by framework concept. Now, update settings and update water tank settings could be considered, oops.
Just click on the screen.
On the screen? Okay, sorry, I touched something. Can you all still see the presentation? Yes, awesome. So what I was saying is that the update settings and update water tank settings classes here could be considered service objects, while the broadcast details and configuration could be maybe serializers. Oops, let me go here. There we go. Now we have explicitly decided not to be prescriptive about how code should be organized inside the domain directories. And this is going to allow the teams to decide what works best for them. Sometimes they organize by subdomains, like they might create a water tank subdirectory. Now, other teams organize their code by patterns. For example, they have services and serializers in their directories. It really depends on where they are in their journey to extracting this code. Some teams actually initially adopted one organization style, but then they end up changing it later as the team grows or their code grows. And that's great because now they have that autonomy to reorganize their code without requiring the whole organization to come along with them. Okay, we're just about done. I'm going to hand it over to Alan to close us out.
All right. Okay. So there are some ideas we want you to take from this talk. I'm going to run through them as quickly as we can because I know we're past 8 already over there. The first is that convex and concave payouts. There are two different investment models that can actually be combined into a single curve to model the application development lifecycle with 3 phases: explore, expand, and extract. Understanding where you are on this chart can actually help you make decisions about the investments you're making in your application. And understanding the route your application took to get to where it is today helps build empathy with the developers who built what you have today. Plus, it helps you think about and prepare for the app you want to have tomorrow. What's the saying? If you forget about history, you're doomed to repeat it. And then finally, we wanted to share our experience with this process. Now, due to how old our app is and due to the growth trajectory we've been on, we found that Rails was both getting in our way and not providing enough structure at our scale. Now, Rails and the lack of best practices back in the day led us to some super large models and controllers with business logic everywhere, even in our views, making our business logic hard to separate and test in isolation. And historically, this has caused us to struggle with complexity and with, obviously, testing. Modularizing our code allowed us to work on smaller, more testable things, and we're seeing the results. Plus, because we've historically had business logic from different domains mixed together in the central concepts of the app, both controllers and models, it's historically been difficult to make improvements. Either we needed to obtain consensus, or one team would force their improvements on everyone. Now, adding boundaries between domains has given teams the autonomy to make those improvements to their own code, as well as accountability for their code. So, how are we seeing? What results are we seeing? So we're actually seeing a massive increase in test coverage. The average coverage for all of our domains is greater than 97% versus about 78% for the application as a whole. Now we know coverage isn't a panacea, but my God, 20% is going to have an impact on the number of sub-1s we see, for example. We're also seeing a corresponding decrease in complexity. The average method complexity in our domain folder is 7.1 versus 10.5 for the code base as a whole. Those are the flog scores. Smaller things are less complex and easier to test. We've also seen a big improvement in things like flaky tests and Sev1 responses, since it's now easy to tell which team owns the bit of code at the center of the problem. Now, most teams are currently at the stage we've just described. There are some teams, however, who've moved far enough along and extracted enough code that they can wrap an API around their code and actually extract entire services out of the monolith. We expect that as other teams get more of their code extracted, they may look at doing something similar. Finally, like we mentioned up front, we're looking for your feedback. This is how to reach us. I'll leave the slide on the screen if you want to take a picture. Do we have time for questions?
Yeah, we have time for questions. Oh, okay. Oh.
Thank you. So one other approach that I've done in large code bases kind of like this for enabling teams to move independently is extracting things into Rails engines. Did you take a look at that and did you experiment with that?
Well, we're a little constrained in that we are on a very old version of Rails. So we have not looked at engines as a global strategy there. We're also a little concerned about with engines, it's possible to reference back outside the engine to concepts that belong, like you should scope the engine. Like the engine should be self-contained. And what we've seen with some of the domain logic that we've seen extracted still kind of has fingers out dangling into the rest of the app. So it's not necessarily an approach. Well, we can't look at it yet. But when we get there, we'll have to consider, is it a strategy that we want to use?
Once upon a time, this is Noel. Once upon a time, I was at a worked on a code base that had done this and extracted into engines. My experience here is it adds a level of complexity, just sort of, you're not decoupling yourself from Rails, you're sort of tying yourself tighter into some weird Rails stuff. The core team doesn't use engines, I don't think, so they don't get a whole lot of love, and it just gets all tangled up. It's harder to manage than
you're introducing a gem. You're adding a dependency.
Well, you're not necessarily adding a dependency. You're just adding a part of Rails that the Rails core team doesn't like put a whole lot of effort into. And my experience with this, on having worked on both heavily engined apps and apps that extracted like this, is that the plain old Ruby objects were significantly easier to manage.
Good to hear.
Using a Rails engine doesn't prevent you from using a Poro or anything like that.
No, but you're putting your
but it
models
does.
in the
You
engine.
have sort of you have a level of complexity just from managing the engines that is it is hard to manage. It's only my experience. Okay, we have a bunch more questions from people who are actually asking questions. Sorry.
Question for you regarding, you mentioned that you're trying to extract some logic from ERBs, basically from templates. So, and you didn't mention anything about like the presenter pattern. Why not have like a presenter class that will just give you JSON, right? If you have a lot of things that do similar things where they present some kind of information about coffee machines, rice cookers or whatever else you guys are managing, why not just have like a class from which you inherit, and it'll just like as JSON, it'll just give you the fields that you want.
Right. Actually, it's maybe I need to do a better job at presenting that section. I did mention it briefly, but yeah, in the view example we used, you know, the whole view could go away and just become a poro. But yes, presenters are definitely a pattern that we are also adopting. I don't know about the inheritance chain necessarily, but responding to as JSON, yes, that's pretty common. But we try to keep them pretty lightweight and just pure Ruby objects.
Got it. Okay.
Hey, Alan. Hey, Fito. It's Kevin. I'm going to ask a loaded question since I know all about this. Can you talk a little bit about how this, in your view, has allowed us to teach Ruby to new Rubyists?
Yeah, that's great. So in order to answer that, I think I need to give a little bit more context on how we're approaching this. And like I mentioned before, we've given this, well, I guess 3 times now. And some of the questions we've gotten before were, oh, how are you enforcing that this is happening? Like, how are you, like, do you have something in CI that blocks people if they're not extracting their code out? And the answer is no. We have office hours, we have videos, we have documentation in Confluence, we have pairing hours that are open for anyone who's working on this. And we have, we're detecting opportunities for extracting work and we let people know about it, but we don't block them. And so what we're trying to do is like teach people this approach so that it becomes a part of our culture rather than a hurdle they have to get over in order to check in their code. And yeah, it's been an amazing opportunity to essentially teach new folk or teach folks that are new to Ruby about, you know, what is Ruby class and what's the difference between Rails and Ruby, and which for people who have been working on this for a while, it might seem obvious, but particularly at Cisco Meraki, we have folks coming in from other parts of Cisco or industry with experiences in, say, Java, or actually, at least once a week, I work with a firmware engineer who spends 90% of their time in C++, but has to add a little feature in our Rails app, and they, you know, need to write some Ruby. Does that answer your question?
All right. Can you hear me? Yes. All right. First of all, thank you. This talk is giving me hope. I work in a code base that's 17 years old, and it is a mess to the point where it's sometimes like hard to find even like where to make the change. Like I'm trying to find the spot where this happens. So I was wondering, you showed that like folder structure, and it seemed that you were kind of moving away from like the regular Rails, like I guess grouping by class class types, right? So models, controllers, like service objects. Have you found that this new folder structure like helps with discoverability of, you know, where stuff is even in the code base?
Yeah, one of the main motivations to like start on this journey several years ago now was that we ran a survey across the entire engineering org, and there were many questions, but the point was like, what's preventing you from being more productive? What's getting in your way? And some of us were surprised to learn that it was actually that it was hard to find where to make your change. And back then the code was basically organized, you know, by Rails concepts. Like code was either in models, views, or controllers, or maybe helpers. And so what we've seen now is people know, like there are directories that organize the code by domain. In some cases, it's not that clear cut. It's not super easy. So we organize them by team. And that's good enough. People know what team they belong to and they know where their code is. And so it's about reducing. I think I mentioned at some point that these boundaries or directories or whatever we want to call them basically help you reduce the cognitive load. Yeah, you no longer need to know about all 4 million lines of code. You just need to know about where your team's code is, and occasionally you have to, you know, go out and interact with our teams or domains. But with usually you have a narrower focus and it's easier to find that other area that you need to change. But the majority of your time you're spending it in your directory, basically.
Can I add something?
Yeah.
In addition to that, because we're giving people autonomy over what their directory structure looks like, it's up to the team to like formulate what's going to work best for them. That means we're sacrificing some transportability of one engineer to another team, but we think it's more important that you be productive on the team that you're on right now rather than your onboarding speed on the new team. So we're giving those teams that autonomy to make those decisions for themselves.
Hey again. So this is a little bit more about the presentation in case you want. Yeah, okay, cool. So you showed a graph twice, which is the number of people contributing to the code base and then the size of the code base.
Yep.
And what was really interesting to me was that that was a 1-to-1 ratio at each point in that chart. Is that a good thing or a bad thing? So it seems like as you showed time as an axis, people were just as productive towards the end of that chart as they were at the beginning. Is that what you were trying to show, or were you expecting it to mismatch in one direction or the other? And then for your presentation, you might want to draw that line with like where you expect it to be going with your changes.
Okay, I didn't quite follow the second part there, but I can answer the question.
All right, so I'll repeat. So like in the chart, like the number of engineers is just as productive at the end of the chart as they were at the beginning, because it's a 1-to-1 ratio, I think. At least that's what it looked like. And so, okay, cool. So you have today in there. So like,
yeah,
what was the effect of the change?
Oh, I see what you're saying. The effect of the change is, we talked about at the end, we've seen code coverage go way up, over 20% over the rest of the app. We've seen complexity drop, measured like statistically important amounts. And we've seen both accountability and autonomy go up. So the autonomy gets to a point where I just kind of discussed what teams are able to do inside their own domain with like structuring it, but they could use different patterns than other teams. Like it's not on them to follow what everybody else is doing. And then on the accountability side, we've seen a humongous decrease in things like the number of flaky tests that we have. Part of that is because we now can pretty readily predict which team owns it. And we run a system overnight where we run a whole bunch of builds off the same SHA, and we look for tests that pass and fail overnight. We then message, now that we know how to attribute that code to somebody, we message that team in Slack. The next morning they get the message, and usually that test is fixed that day. We have a system for automatically skipping them as well, but it's had a significant impact on our ability to react to something that historically just didn't get any attention. Because you get a flaky test on your build, you don't know where it goes, who it belongs to, but now it's possible to figure that out. And in addition to figuring that out, we also, like I said, have this system that will prevent you from hitting it the next time. So at most it's only in the system for about an hour.
I have a question. Is your question about how the changes are going to affect the number of lines of code and the number of developers in the organization? Was
pretty much. I mean, what I'm pointing out is that like that's what this chart is showing, and so like I'm guessing that your point is like the green bar would be much lower without your changes because people would be way less productive.
I see. That's super hard to measure. This is more. I think the intention here is this is happening. Like we were getting more and more people onboarded, and they're writing more and more code, and so it's increasingly more important that they know where to go make their changes, that they feel like they're productive in this code base. And I guess you make a good point. Maybe this would have been lower with the same number of people, but that assumes that lines of code is a measurement of productivity, which I'm not sure. It's a very good question. I'll have to ponder.
Yeah. Sorry, you don't have to change anything, but like another alternative y-axis you could have here is like PRs shipped, like changes being made to the system, something like that. Might be worth looking at.
Yeah. We use the term cycle time, which internally, maybe that's something we can look into. There's so many moving pieces that it can be super hard to.
Yeah, cycle times is hard. Thank you for the feedback, though.
Yeah.
Appreciate it.
Hello. Any more questions? All right.
I have a question.
Oh.
How many of you are going to come see this at RailsConf? Anybody?
RailsConf is in Philadelphia. It is, Philadelphia in July 9th, 10th, 8th, 9th, and 10th. Tuesday, Wednesday, Thursday, whatever that week is. Chime will be there as a sponsor as well.
Right on.
Great. Well, thank you so much, Alan and Vito. Great. I think we're pretty much done for the day. Yeah. If there's any more food, feel free to take more. But yeah, that's a wrap. Thank you so much for coming.
Thank you so much for having us.
Thank you.
Thanks, Alan. Thanks, Vito.